Okay, so in worksheet 15, there's a lot of exercises that are classic exercises, and I don't want to ruin the fun for you. So I'm making up a completely different one that is not standard so that I can do it and show you all the pieces of how this thing fits together. So here's this object I want you to imagine. Okay, so I have this curve y equals x squared, and I'm going from 3 to 5. So on the y-axis, I'm going from 9 to 25. Okay, and I'm going to build equilateral triangles. So if I take this object and turn it, it's going to look like, it's going to have kind of like an equilateral triangle, and then it's going to have a swoop, and it's going to have equilateral triangle on the other side. That if you, I'm going to make it gray so you can see what's hidden behind the object itself. It's going to have an edge there, and then it's going to have an edge here. And I want to visualize this three-dimensional object, and now I want to find the volume of that. So for each little slice, if I take a slice out of a slice in this direction, okay, like a slice out of the middle of this thing, there is the x value that I took a slice from. The height of this thing is going to be like x squared if you look at it on the side, but it's going to be like a triangle coming out on each side, right? So can you imagine that it's actually, if you look at it straight head on, it's very thin at the top and very thick at the bottom, but it's just a rectangle, like a slab of this stuff. But then if you turn it on its side, you're going to see the height is x squared. So let's figure out what this means if it's an equilateral triangle. What's the area of this thing? So where does this thing actually come out? And we know an equilateral triangle is going to be a 60, 60, 30 right triangle when it's split down the middle. And we know a 60, 60, 30 right triangle has a ratio 2, 1, square root of 3. And so if the height is x squared, then how do we find out we need to know this length here, right? So we have to set up some kind of ratio, right? So we have x squared is to what we don't know, q is what we're looking for, is the same ratio as square root of 3 to 1. And so we have q square root of 3q is equal to x squared. We're looking for q is x squared over the square root of 3. So that's this distance here is x squared over the square root of 3. I'm going to clean this up a bit because I want to talk about the area. What is the area of this triangle? It's 1/2 base times height. So we already have 1/2 base times the height. So the surface area of this thing is going to be x to the 4th over square root of 3. Okay, so that's the surface area for each little x slab, and then the volume we get from the dx. So what we're going to do is we're going to integrate from 3 to 5 of x to the 4th over square root of 3 dx, and you guys can do that yourself. This is not mysterious to you, and you can always double check that answer on Wolfram Alpha if you want. Okay, so I'm not going to actually solve this. I just wanted to set it up for you, and hopefully you can visualize that. So as you're doing these exercises, what you want to do is always in your mind make a model, do the best you can to draw what's going on. Here are some examples of things you might want to draw. Okay, mostly it's going to be a lot of circles. Let's just be honest. We're doing a lot of volumes of revolution. And so you're going to do things from like here to here, whatever they are finite. We're not doing a lot of infinite things when we do revolution. Sometimes we do. Most of them are finite. And so there's some kind of curve here. And then what you're supposed to do is imagine putting this on a lathe, and then you're going to get like a mirror image of the same shape down below. And then this whole thing is going to be like a dx strip here, and then you're going to rotate this whole thing around as a circle. So what's going to happen is whatever y is some function of x, is going to end up being the radius of a circle. So you're going to end up with the surface area as something like pi r squared, and then you're going to use the dx slice. Okay, and so that's a very common thing. You're also going to get problems where you have to wrap it around the other axis, and that's very similar. You just have to keep your wits about you. because X and Y are just letters. And if you wanted to rotate around this axis, that's fine. And it really doesn't matter. But then you're thinking instead of Y as a function of X, X is a function of Y, and that just messes with your head. But it's really identical. You just have to kind of visualize what's going on. If you're rotating, then this X value becomes your radius, but it might be in terms of Y. Okay, so just keep that in mind. So if you haven't noticed, with Robinson's videos, once in a while he drops in something that isn't just lecture, it's something very active and physical. And so you might want to watch him slicing some wood in our backyard. And that's at approximately minute 1 and 45 seconds. Anyway, it's a pretty short video, and he had a lot of fun making it. So you might want to watch some of his active video portions. Anyway, for what it's worth, that wood came from our neighbor's property, because we've had like 3 trees removed since we moved here, but our neighbors also had to have a tree cut down, and so they, I just was like, oh my gosh, you're having your trees cut down, can we have some of your wood? And they're like, yeah, sure, take some. And so that whole big pile of wood is actually from our neighbors. So anyway, hope you had fun watching this video, and I hope you have fun with slices.